Our next talk will provide an introduction and survey of existing and future boards used to interface and reverse engineer electronic equipment. We present Bruce Barnett with Let's Have a Board Level Talk, i.e. hardware interface boards.
Good evening. I'd like to say how great it is to be here and to see everyone. Well, I'd like to. So I'm going to pretend that I'm seeing everyone in a great audience, and you can pretend that you're enjoying this talk. Why learn hardware hacking? It gives you knowledge, it gives you insight. You learn how to, for instance, access consoles of embedded systems, reflash firmware, unbrick a device, extract and examine the firmware, change the firmware. You can also learn how to reverse engineer systems, which lets you investigate the security of these IoT devices. And really, one of the goals is to help improve security of products sold to the consumer. It also gives you the tools to learn how to debug and fix and create your own equipment, your own electronics. So, who should attend this talk? For those who are starting out, what makes sense to buy? After all, some equipment's very expensive, and some of it's obsolete, and some are difficult to use. So I'm trying to provide some guidance to those who want to get into hardware hacking and also help those who have some experience and looking to maybe learn a few extra tricks or a couple extra techniques that they might find useful. Which way to go? So that's what this talk is about. Also, you'll notice that sometimes I describe equipment and I highlight certain equipment in yellow. I do that because I think it's a good buy. It's a lot of functionality and the price is pretty reasonable. Well, that's enough about me. Here is a tool list of equipment that will be useful when you get involved in hardware hacking. You don't need all of it. As a minimum, you just need a multimeter, soldering iron, and a protocol board. And that's what I'm focusing on today is the protocol boards. And you can get by with total of $40, $50. And as you get more experience, you can add more equipment to your list. What is out of scope is anything to do with wireless. No Wi-Fi, RFID, software-defined radio. I'm not going to cover any physical layer protocols. I'm not going to cover anything to do with your automobile. No chip layer attacks and no side channel attacks. Since this talk focuses on hardware protocol boards, these are the protocols that are used to interface to embedded systems. First of all, there is their firmware or bootloader installation. This is sometimes referred to as in-system programming, or Arduino uses the term in-circuit system programming. Another protocol is a serial interface for terminals. I2C is used for a lot of sensors. And another very useful one is SPI, Serial Peripheral Interface. This is a high-speed protocol that is used for displays and reading and writing flash memory. The JTAG protocol is a very complex protocol that allows for the in-circuit testing and debugging of chips. A variation is a single-wire debug for ARM chips, and another protocol we will be taking a look at is USB. Now there's one serial interface that's very simple and very easy to use. Well, not that easy. And besides, I'm not trying to spoon feed you information. I'm talking about the Universal Asynchronous Receiver Transmitter, or UART, essentially the terminal. Now, a company that developed a very useful chip was FTDI. They developed this chip that would convert a USB interface into a serial interface. It was a bit expensive, and a lot of clones eventually got developed to copy this chip. FTDI had an interesting response of modifying their Windows driver so if they detected that the chip was a clone, it would brick it. Caused a bit of a reaction. They still make products. They still make some very good products out there. And you might see this product still today. They have cables used, as I have shown right here, that plugs into your USB port and provides a 4-wire connection to your serial interface. There are some more versatile boards out there that allow you to have more functionality, LEDs, and things like that. There is one board I just found out about, and I show a picture of it. It's by DSD Tech, and it's based on the RT232RL chip, and it's only $12, and it provides 4 different voltage levels on a serial interface, which is pretty unusual. And for $12, it's much cheaper than the other products, like the one, for instance, that Adafruit sells for $15. Now, there are other chips that will do similar things at a lower cost, not quite as versatile as the one that I've mentioned. We tend to think of electronics as a big black box, but let's look inside. There are more than 10,000 different microcontrollers out there, and every vendor has their own preferred solution for programming and debugging these devices. Sometimes they refer to them as an FET or flash emulation tool. I have listed some of the more popular ones out there, and some of them, you may notice, can be very inexpensive. You can get a clone of an ST-Link, for instance, for $2. There are a few people that prefer to use open source tools. There are many open source programs that will give you access to both proprietary hardware and open source hardware. If you want to access a terminal interface, for instance, that's pretty simple. You can just use PuTTY or Screen or Minicom. If you want to access an I2C sensor, for instance, you could first of all use I2Scan to identify the addresses and use some Python libraries to get access to the individual sensors. Now, if you want to access SPI, typically used for reading or writing various flash memory, there's several programs. AVRDude will do this, FlashROM, and some Python libraries. Now, when it comes to debugging, SWD, for instance, you can use programs such as OpenOCD, GDB, or URJTAG. They'll also work with the JTAG interface. And also, there are many proprietary hardware reprogramming protocols, and AVRDude will work in many cases for those protocols. Using proprietary hardware has always been a struggle for hackers. Early programmers for the Atmel microprocessors were quite expensive, $200, for instance. Now, some software was developed to make use of these. AVRDude was created by Brian Dean in 2003, but it wasn't until 2009 that the Bus Pirate and the GoodFET both came out. I'll talk a little bit more about those later on. Dick Streisand created the USB Tiny, which is a do-it-yourself kit of making your own AVR programmer, and you can still get these kits nowadays. Adafruit sells one for $22, and I show that one on the left. There's also another one that I just got from Geppetto Electronics that's cheaper, and it has some nice features. It's different voltage levels, and there's extra protection on that. It only has the one 6-pin connector, while the Adafruit one has both the 6-pin and the 10-pin connector. I should mention that these programmers are used to put new firmware into Arduinos. As I mentioned, the Bus Pirate is one of the First, protocol boards. It can understand UART, and you can use it for I2C and SPI, and just a little bit of JTAG. It's a nice device. I really like it. It's very old school, but it's very flexible. It has, for instance, it has a UART-based interface. That means you just connect to it using PuTTY or Screen or whatever, and you have access to all the functionality. You don't need additional software to make use of it. It has onboard pull-up resistors that you can turn on and off from your computer. There are different power levels that you can hook it up to. There's an A to D input pin that you can use to measure voltages. You can even use it as a very simple oscilloscope. There's macros, a basic interpreter, a waveform generator, but you can use it for data logging. And it works with most open source software, such as AVR2, Flash-ROM, Arduino for reprogramming Arduinos, and also for OpenOCD. Now there's two versions. Version 3 is the older one, and that uses the standard cable. You can buy these cables, such as the one I have shown there, and plug it in and make use of it. However, because it's 10 years old, it's running out of memory. There's not a lot of extra room. In fact, there are different versions of the firmware, and depending on what features you want, you put different firmware in because you can't get everything. Now there's version 4. It has more memory, but it has a different header, so you can't use a standard cable. And also, to quote one of the developers, it's a little flaky. Now there are some other problems with the Bus Pirate. One, the biggest one perhaps, is that it's old and slow. For instance, if you want to flash a ROM, it might take you 30 minutes, and on a modern board, this could take 30 seconds. There's also no low-level API if you want to get involved into low-level programming using Python or something like that. It's a little difficult to do. There are other multi-purpose protocol boards out there, and several of them use a chip developed by FTDI, which I've mentioned earlier. It's the 232H family. This chip is a multi-protocol synchronous serial engine, and it has support for UART, SPI, JTAG, and SWD, GPIO, a lot of functionality in there. Now, the first chip they developed, the 232, has support for simultaneously two different hardware connections. So you can have a JTAG and an SPI connection and support both of them with the same chip. And the first three boards I've listed below use the 232. The other boards use the 232H chip. And in particular, I wanted to point out the one on the bottom by a company in China, CJMCU. And you can get this board, I've shown a picture of it, for between $7 to $15. It comes with the headers. You have to solder the headers onto the board yourself, but it's a very functional, powerful, and low-cost chip. There are a few issues. If you want to use a serial interface, that's fairly easy because you don't need any additional software to make use of that. You can just use PuTTY to do that without anything special. If you want to use the other protocols, you're going to need some sort of libraries out there, but they're available. There's several Python libraries. There's a couple different ones, and they're not quite identical, so you may have to play around with getting the right one to work with the different one. But all of the open source tools I've mentioned will support this chip. Also, one of the problems is that the tutorials are really spread out all over the place. There's not one massive common source that has all this stuff well documented. I was looking, for instance, how do you hook up an I2C device to these chips? And I had a hard time finding the documentation on there. For instance, you need a couple pull-up resistors and you have to add them yourself. Also, the SWD wasn't well documented. And there is another problem that if you wire up the board that you're debugging and you hook up one of your power lines on the board to one of your data lines, you short them out by accident, it could go through the chip and get into your laptop and possibly damage your laptop or desktop. Now, one thing that you can do to protect yourself is to have a hub in between your chip, that's your protocol interface board, and your laptop. And if the hub has a fuse on it, that would be good, but you don't always know if it has a fuse or not. Now, I will mention that one of the boards that I have described on the last page, the Sheikra, that has a built-in fuse to protect your laptop from this problem. Now, there are two boards that address these issues that you should find very useful. The first is the Shukran board. So you take your CJMCU breakout board and you plug it into this board, and it provides additional functionality. The second board is the Focaccia board. You take your CJMCU breakout board and you plug it into Focaccia board, and you have additional functionality as well. Let's talk about how these two boards are similar. They both have jumpers so that you can turn on I2C mode and to turn on the pull-up resistors when you want to use them and when you don't. It also has a jumper to select the voltage you want, 3.3 versus 5 volts. And they all have headers so you can plug in I2C, or if you want the 3.3 volt or 5 volt or ground, and you want to connect this to your device, those headers are already there. Now, the Shukran board on the right, well, first of all, it's smaller. That might be important to you if you're short of space. It also makes all the pins on the FTDI 232H chip, all the pins are available if you need access to it. It also has one other feature that is nice. It has a built-in polyfuse in there to protect your laptop from being damaged by a short on the board under test. Now, the Focaccia board on the left, it has a lot of additional headers. It has, for instance, a built-in header for SWD and JTAG and UART, so you can just plug something right in. It also has a special spots for a SPI test clip, and if you want to plug in a socket for surface mount devices, you can plug that in and make use of that. There's also extra connectors they provide on the end that you can use as a sort of a mini breadboard, so you don't need additional hardware to hook up a bunch of wires. And I think the labels are much easier to use. It's a bigger board, but it's a lot of convenience in that. Now, as to the cost, the Focaccia board is commercially available. You can buy it for $10. Now, the Shukran board is not, but they provide on their GitHub page directions on how you can get the boards made through a company, and also the parts, and I followed their instructions. Since you have to order 5 boards, and by the way, I've never ordered a PCB before, but I found this fairly easy to do. So, and since you have to order a minimum of 5, I changed the BOM, the bill of materials, to which was only had the parts for 1 board to make it enough parts for 5 boards. So I modified the BOM a little bit, and I used the suggested software and websites to do this, a company in China, and I used a first-time user $2 coupon, and I was able to get 5 boards and the parts for all 5 boards for a total cost of $7.75. So that's $1.55 each, which I thought was a pretty good price. And like I said, it's pretty easy to do. So all you need to do is add your FT232 chip onto the board. Now, there is another big difference. When you solder the header onto your breakout board, the Shukran board, the header goes underneath the chip. In other words, the chip is on the top of the board, the header is underneath, and when you plug it into the shoot grant board, you can see the chip. The Focaccia board, it's the opposite. When you solder the header onto the chip, the headers go on the same side as the chip. So when you plug that board onto the Focaccia board, the chip is underneath. You don't see the FT232 chip, and the picture there should show the difference. So be aware of that. And both these boards will really make your life a lot easier if you make use of them. I should mention two more things. The first is that since the shoot grant board is a do-it-yourself, you have to solder it up yourself. There is a couple components that are surface mounted, the Polyfuse for instance, but the pads are very large, so I did not find it hard at all to solder those two components onto the board. The other thing is the Focaccia board, it has those sockets that you can get different, plug in different SMT sockets onto the board. And you can get several different 8-pin sockets for different size flash chips. So that's very convenient. You can just change the socket, plug a different socket in, and if you unsolder or surface mount a flash chip, you can put it into the socket. You can use that to read or write your ROM. There are several specialized boards that I'd like to mention. James Bowman has a company, X-Camera, and he makes these two dedicated boards. They both have Python interfaces, and one's just for I2C, the other one is just for SPI. But the nice thing about them is they have a very nice display, and they show you the logic levels of what's going on, and they measure the voltages on the board, and it could be a very useful way to diagnose problems that you have with these sort of devices. Another board that's very useful for professionals is the JTAGulator. One of the problems you have when you're trying to interface, reverse and engineer a board is trying to identify where the JTAG or UART interfaces are. Now you can do this. There's some software that you can put on Arduino and make use of this, but they're limited in the number of pins that they have. The JTAGulator has 24 pins, and you can hook up all 24 pins and tell it to do a brute force search of all the different pins and try to identify UART and JTAG interfaces. So it really can save time compared to doing it manually. The Hydra Bus is another general purpose board I haven't used myself, but it has a lot of features and I wanted to mention it. And in particular, it has an NFC shield that some people might find useful. A very good debugger is the Blackmagic Probe. This allows you, especially if you've got your own source code and using the GDB debugger already, this allows you to integrate your debugger session into the hardware, so you can test your hardware using your own source code. It's like ST-Link, but this is all open source. It only works with some processors, but it does use the standard GNU software toolchain, which is very nice. There are some debuggers you have to use OpenOCD as a way to hook things up, and this you don't need to do that. We'll work with different operating systems. Now, one thing to mention is that because it's open source, people have developed clones of this device. On Amazon, for instance, there's something called the Jeff Probe, which is a lot less expensive, and another one I've seen on Tindy is the Bumpy, and that's only $12. I've even had reports of people who've used a $2 ST-Link V2 clone they got from China, and they put some of the functionality of Blackmagic Probe onto those devices. I've mentioned the GoodFET before, but that's pretty much obsolete. It's been 10 years and we need something better. So Michael Osmond created something he's called the GreatFET, and this is designed for the future. It has a lot of capability. It's an FPGA base, so it's got a lot of performance. There's 2 USB ports on it, which means that you can do some USB protocol hacking. It's got 100 I/O pins. It has support for all the different protocols on there. It has a logic analyzer in there, an A to D, and It has a lot of functionality. Some things it doesn't have. It only has like one voltage level. So you need to, what they call, plug on neighbor boards onto it to add additional functionality. So there's plans, for instance, for a radio or IR, or maybe a software-defined radio, level shifters to handle different voltages, infrared. They've sort of planned for the future for this device. Now, one of the things they've done recently with it is that I think it's really, really kind of cool. They've made this as an add-on to the software-defined radio. So you can use your GNU Radio Companion and you plug this board in, and this allows you to hook up a DSP onto your software-defined radio. And for instance, they've used this to take a little $2 module, hook it onto the GratefET as a DSP, process it, and make it into a guitar preamp. Now, there's a lot of other things that this device can do, and the software is constantly evolving, so it's really a board for the future. There's some functionality in there. If you like looking at what the next generation board is going to look like, expect to see a lot of things coming out of the GratefET. I'd like to talk about some of the boards that are coming out in the future. I don't know which ones will handle the flying cars, but there's some still exciting boards out there. For instance, and you're interested in USB protocol hacking, well, originally there was one called the Face Dancer, and that was replaced by the GratefET. It was designed for USB hacking. But Kate Temkin has taken the GratefET and she's decided to come up with a specialized board just for USB hacking. She's called the Luna board. And don't know when that's coming out, but you may want to keep an eye out on that. Another board that is supposed to come out is the replacement for the Bus Pirate, called the Bus Pirate Ultra. Apparently it's in beta test. I don't know a lot about it, but some of the specs do look pretty interesting. Now, one of the things I liked about the Bus Pirate is it had a lot of the software integrated into the board, so it made it really easy to use. And this board, for instance, is going to have, first of all, it's going to have both a CPU and an FPGA for performance. There's also a connector for a display, so you can plug in the display and you might be able to make it a self-contained unit. It's going to have a programmable power supply, and it's going to have 8 pins. And like the Bus Pirate, you can measure the voltage on each of the I/O pins. It's going to have pull-up resistors that you can turn on and off. And it's designed to be like a built-in logic analyzer that you can use. It would have a second USB connector if you want to do data collection while you're using it. And that's really exciting, but I have no idea when it's or if it's coming out. There's another board that I'm really excited about called the Glasgow board. And you can sign up on CrowdSupply to get part of the mailing list to find out when it gets released, because it is going to be coming out. Now, this is a general purpose board. The way the author describes it is a combination of Bus Pirate and Bus Blaster and Logic Sniffer all as one. It's got 5 different voltage levels that you can select from, and it has 16 pins, and apparently software-wise you can make the 16 pins connect to anything. You don't have to have dedicated pins hooked up to particular protocol pins. And it's got an FPGA, and it's supposed to have a lot of functionality. And they estimate, I saw one estimate of about $100 for this board when it comes out. But there is one of his colleagues, or one of his friends, I guess, who's coming up with a board that he's trying to make it more economical. He's called it the Edinburgh board, and it uses some lower cost parts and maybe a different manufacturing process to lower the cost of this. And so both these boards are coming out, so keep an eye on those. Now, the same person who developed the low-cost Focaccia board and also made it available for purchase has hinted on a new board he called the Berlina board. And again, it looks a little similar in maybe concept where you take these breakout boards and you plug it into this board and add some functionality. All I know about it is this picture, and I'm looking at it, and it looks like it's got an ESP8266 chip on there, and maybe a long-range radio. So this might be a board that can be used for exploring some wireless protocols. So keep an eye out for that. It looks pretty interesting. Now, I hope that I've showed you that you can, once you have a multimeter, and I can recommend some low-cost multimeters, and a soldering iron, and for the cost of maybe $20 more or a little bit more, you could get yourself a hardware kit that lets you get access and start learning how to do some hardware hacking of embedded systems. Now, I've got some recommended resources you might find useful. There's this one gentleman from the Netherlands called Yilis, who has a set of streaming videos where he shows people how to do it. And it's called Avoiding Warranties. And for instance, the first one I've listed there shows him how using just a multimeter and a UART interface to identify the UART connections of a WRT54G, and he goes through step by step how he goes about doing it. So that's all you need to get started. And once you have some hardware you want to take a look at, and the techniques used for that particular router, you can use for other devices as well. So that's a great introduction, and he has a whole series of videos showing how he hacks into various devices using inexpensive equipment. I've also included Mark Carney's book, which is a draft of a book on pen testing hardware and a list of curated resources. There's also a podcast for the Unnamed Reverse Engineering Podcast that you find useful. And I've got my own website and my own Twitter feed that you might find useful as well. So, now you're all set. I've given you a selection of some tools to get, some that don't cost too much. Find a device to hack. Open it up, see what you can discover. And you don't want to destroy your equipment, so remember to find the ground on the device first, find all the different ground points, measure the voltages, and once you have the voltages, then you have a better idea of how you connect your hardware onto this board under test. Then you try to discover the interfaces, and you've got the tools. Now, you've mentioned the software. Now you can learn how to use the software and find out how you can, read the ROM, try to reverse engineer it, try to look inside for information, see what you can learn, and be sure to tell your friends what you discover. Here's a list of Twitter feeds that I found very valuable to me as I learned how to use this equipment. And I want to give thanks to them, and perhaps you can also follow them as well on Twitter. So thank you for hanging on to the end, and I hope you found this talk useful, and I'll be glad to answer any questions that I can.
This is Let's Have a Board Level Talk with Bruce Barnett. We'd like to invite those of you attending Hope 2020 to ask Bruce your own questions. Please post your questions to the live stream Q&A channel in our Matrix chat, and they will be relayed here. Bruce, we have a question from the audience for you. The audience member asks, you mentioned some of the companies you order from. Is it possible to avoid some of the low-cost Chinese companies? Do you have preferred suppliers, or mostly just focus on the least expensive?
No, I do a lot of purchase when I get involved in the early crowdsourcing and the crowdfunding stage. I've bought a lot of the products, and I do that because I want to support the developers, the people who are doing the hard work, the people who are doing the creative work. I try to buy from them when I can. And if I can't, I try to see if I can buy from some recommended resellers of the product whenever possible. Sometimes for some of the low-cost boards, I get them because they're just the $5 or $7 boards, no big deal. But the higher quality boards, the boards that really show the creativity, I try to buy them from the originators when possible.
A member of the audience asks, many hackers try to foster curiosity around youngsters. How would you suggest taking some of your talk's ideas to the younger generation?
Well, I think one of the things that I tried to point out is that you can, for just maybe $20 or so in hardware, you can start having some hardware that you can use to start exploring with, probing around with. I mean, you can also use it to interface to your own, digital electronics if you want to, debug some Arduino code or something like that. Everything, the Arduinos always have SPI or I2C interfaces on them, and you can try to drive them directly yourself. And you can also learn to use Python to interface to these things, because most of the boards I talked about have a Python interface. So you have that as a programming language to play around with. So I think that's a pretty good start for something low cost to let them play around with some of these things.
A member of the audience asks, what's your preferred debugging environment? I've used GDBTK to work on an ARM7 platform running VxWorks using JTAG for ICD, but I had all the source that I was tracing through. If you don't have the source for the running embedded system, then what are you using to do your tracing?
Well, I have to, pass on that. I can't really say I have a preferred recommendation for that. I think it's best to learn what you know or what you have the resources to get into. It might require some people that can give you some guidance, or maybe you've got some people from work who support some commercial tools you might find useful. So it all depends on your own environment and your own teammates.
We were asked, can you suggest any good USB oscilloscopes?
Well, there's expensive ones and there's cheap ones. The cheap ones tend to go about $50 to $100 or so. A lot of people have said, now the USB ones are great for portability. And I think I've got some that will fit in your pocket. But a lot of people say, if you really want to learn to use an oscilloscope, save up your money and get a real one. There is one that list price is like $350, the Rigol, for instance, and I was able to pick one up, used for $200. And if you're talking $50 to $100 for a USB one, you can get a real world-class oscilloscope, 4-channel for $200. If you can do that, that's what you can do. But other than that, just try it. I've bought several USB oscilloscopes, and the money I spend on all of them put together, I probably could have bought a real oscilloscope.
What qualities do you look for in an oscilloscope if you're shopping?
Well, a lot of people like 4-channel, because then you can do some logic analysis of what's going on. That's kind of useful in this work, especially with some of the protocols like SPI and I2C and all that. 4 channels would help an awful lot.
An audience member asks, some of the audience were talking about cyber physical systems like battle bots. Any guidance on how to approach this?
No. I'd like to play around with it, but I just don't have the time. Redundancy.
Sure. We were asked, do you have any opinion on the Espotec Labrador?
No, I'm not familiar with that. One thing, I want to mention one thing. That Bursina board that I was mentioning is just coming out. I just noticed the guy announced it about 6 hours ago. He announced that the board is now an open source board, and you can get it, and he plans to make it available at a low cost. And it has you can plug in a Node MCU and a TI CC 1101 chip for a 1 gigahertz radio. So it sounds pretty interesting. It's It's supposed to have the capability of automatically detecting UART interfaces on a board. So that sounds kind of sweet. One other thing too, my Twitter feed, I have a list that I put together for this talk, all the people I've recommended that you can follow on Twitter. If you go to my Twitter account, and I have a list called Hope 2020. If you click on that, you get all the people that I mentioned in the talk that you can follow in one click.
And what's your Twitter username?
Grimoire, Grymore.
A member of the audience asks, what are your favorite information resources for news about forthcoming boards, for sharing information about how to use some of these new boards?
It's that Twitter feed I just mentioned. That's where I find out about this stuff, and I learn about these things. So it's been that, and you also find out when things are coming out, and it gives you some insight as to, here's some new boards coming out, or here's a new crowdfunded project that we're working on. So that's how I keep in touch with these things.
Are there any in particular that come to mind as just ones you really like or get a lot out of?
I'm really trying to learn as much as I can about these things. I'm trying to study up on them and write better tutorials on them to let people know how to use them. And that's been my goal right now is learning and sharing what I've learned from this.
We've got a little bit of time left. Please keep your questions coming to the session Q&A channel in our Matrix chat. Yeah, there's definitely a lot of activity going on in our Matrix chat, and I highly recommend that for anybody watching Hope Talks. Just get involved, because this Hope, unlike other Hopes, you can talk amongst yourselves in the audience without being rude, which is neat. And
I'll join in a few minutes as soon as I get off this. So
we're being asked to repeat the Twitter username, the Twitter feed.
Grymore.
Grymore.
Grimoire
On Twitter. And yeah.
It was on all my slides too.
Excellent. You are watching Let's Have a Board Level Talk with Bruce Barnett.